Good morning, everyone, and welcome to our first AATF virtual conference. This is set up to be an exciting prelude to the AATF 2023 event. We have an amazing lineup of speakers across the next 2 days. And first up, we have Hermes Hendrickson from Siemens. Hermes Hendrickson was first exposed to digitalization technology in 2007. At which time he was completing his Bachelor of Engineering at the University of Pretoria. While completing his postgraduate studies, he continued implementing training consulting on technology solutions in industries such as automotive, rail, heavy equipment, military, marine, mining, and CPG throughout South Africa, as well as internationally in the Middle East and USA. He currently holds the position of the Portfolio Development Executive at Siemens Digital Industry Software in Pretoria and is continuing studies in his Master's in Engineering focused on digital enterprise. His professional goal is to bridge the gap between engineering, IT, and business by leveraging technology to create tangible value. His topic today will be removing barriers to IIoT. And this presentation will practically show how anyone can start investigating how the industrial Internet of Things can add value to their organization without incurring initial costs. Thank you, Hermes. Over to you.
Thank you very much, Ivashni. So let me just share my screen. So welcome to the presentation. Sorry, I just want to, my screen's jumping around. I'm sure you would have, I definitely would have preferred to meet face to face so we can interact on a personal level, maybe grab a beer after the event, but obviously things have changed. I think we're a bit settled more into the new normal. There's a lot of challenges professionally, personally. I have this one picture that I took that just explains everybody's going through things, but what's important to note is there's a lot of opportunities being brought about with these changes. So the agenda for today, I'll be going through what exactly is, why is industrial IoT such a big deal? How do we remove the barriers to it? And then also what can be done today, just on a practical level. So running into why, there's a Greek philosopher called Heraclitus that he famously wrote back in 500 BC that the only thing that's constant is change. And we've seen this, technology only accelerates this. And if you take a step back and look at the past 2 years or 3 years, it's very obvious of this trend, and things are happening very quickly, and we need to adjust and adapt to it. So if we look at 2021, let's forget about 2020 for a moment. I think everybody wants to. The pandemic disruption, it's forcing things to change at a rate unseen before. But what this means is that there's this massive innovation, again, being driven by technology. This remote workforce that's becoming the norm, and it needs to be used properly. Multi-experience is becoming expected, where you want to be able to just have your phone with you and be able to work, or use VR or AR. All these data technologies is becoming more of the norm. And what we need to do with that is we need to harness this momentum to really make use of it, where there's a lot of new talent, new technologies, and there's at the same time a lot of experience in the market, and we need to bring them together. The challenge around this is there's an explosion of complexity. This health and safety is obviously top of mind, but at the same time you want to be scalable, you want to have high quality products, want it to be personalized, efficient. There are so many things to address and to work with that it becomes a challenge to address properly. And this is where it comes to why industrial IoT is such a big deal, is because it connects all of these dots. It's actually a very broad term, and if you ask different people what it means, or if you just look at what the words in the definition are, you'll get a bunch of different answers. But what it comes down to is business has demand. It's a business problem we're trying to solve. We want to get products to market quicker, we want to digitalize, we want to innovate. But IT struggle to keep up. They simply don't have enough resources to be able to handle all of these ideas coming in. And sorry, is my screen still being shared? I just want to double check.
Yes, it is. You can carry on.
Okay, sorry. Yeah, so there's a gap between business and IT. What often happens is business starts developing what's called shadow IT, where it's what we call a citizen developer. Is someone typically they have a problem, they want to solve it, so they just quickly let's say build an Excel spreadsheet to solve it. That's not under control. IT doesn't know about it, doesn't have proper security, so that could cause issues. And if you look at industrial IoT, what happens there is not only that, but you typically have to outsource experts to look into it, or there's a cost and or complexity barrier to entry to really start leveraging the potential of industrial IoT. So now how do we remove these barriers to entry? So I'm going to go through this quickly. So I work for a division within Siemens called Digital Industry Software, and we're the number one industrial automation, industrial software. We're number one industrial automation as well, but number one industrial software company globally. And what we do, if you look at this picture, is many people know of the Siemens automation, let's say, layer, but in what we've done for so I'm just getting feedback. Oh, thanks. So what we've done over a decade is made a lot of acquisitions to complete what we call the digital enterprise vision. And I see there's a lot of technologies, and bringing them all together, and again, looking at that digital thread of how to do they all connect is a challenge that we face ourselves, because we use our software on a day-to-day basis. And the rest of this, I'll go into what we've done to address that. So if we look at the digital enterprise, it's basically connecting the physical and the virtual world. At the same time, you want to maintain your security around the connections and also the services to support this. It doesn't help you have a lot of hardware and software, but there's no one to support that. So through that, we also have a large partner ecosystem globally to work with and to help support this vision and to drive it out. From just a naming convention, it's called our accelerator portfolio, and this goes extremely broad. You'll see there's a IoT analytics, just let's say, written there on the side, because it's only one aspect of this holistic digital twin. What's important to really make this work in practice is that you have this comprehensive digital twin. So that's obviously connecting from, let's say, from the IP generation, from the idea. So I've seen the chat, my screen is not, they can't see my screen. Okay. Is it still on the first slide?
Sorry, Hermes, can I ask you to just reshare again, please? Apologies. There we go. Thank you.
Okay, I'm going to jump forward slightly. So let me just skip forward. So at maybe, so I just want to get my thoughts in line. So a big thing with industrial IoT is it's connecting the operational technology and the information technology. So it's that convergence of IT and OT. So we have the accelerator portfolio, and as you saw, there's a lot of technologies, there's a lot of layers, and even within ourselves, within our own organization, we've seen this is complex. How do you get someone that they're only aware of potential value to really leverage this? How do we make it practical? How do we make it easy? How do we remove those barriers, the cost, the complexity, to at least start investigating it without going full out and having to have a, let's say, 18-month project just to understand if it would add value? So the different layers that we do have is obviously from the automation layer, and a big thing is that this entire ecosystem is open and flexible. So these layers can be interchanged with different technologies. Obviously, there is a Siemens technology stack, but it's not a prerequisite to really leverage this. So it goes from your automation on the floor through to your edge, which is becoming very popular but necessary these days, into your Mindsphere layer, which is our industrial IoT system that hosts and gathers the data and onboards devices. Then at the top, we have something called Mendix, and you'll see the small MX logos. It's almost everywhere, and that's a low-code platform. As a general term, it actually does. I'll go a bit into more exactly what it does, but that's where we're seeing this is really making sense and helping people really leverage this. So you might have asked, okay, I didn't really answer, how do we do this? So how do we practically do it? From a technology standpoint, and I'll go into what you can do after this presentation actually, but from a technology standpoint, what Mendix does is it's no code, low code, and it's a full code in one platform. So the advantage of this is you get your citizen developer that I mentioned earlier, instead of going into something like Excel or Access or any standalone tool, they go into something like Mendix where they can use no code. So that's drag and drop, set up a framework of this is what they need to address that business need. At the same time, IT sees what's happening. They can enforce security, logins, all that IT heavy things in the same environment. And in between, you have your low code where your business analysts and your engineers, they might want to drive the process where, okay, this is the business need, but for this to happen, we need to integrate into the X, Y, and Z systems. We need to show our suppliers certain things. We need to share data with our customers, help them interact with us better. So they can build those workflows and expand on this. So what this enables, this approach, is literally, and these are not our numbers, this is low code as a discipline, it's up to 10 times faster with 70% resources to develop that business value, that idea, that application. And an application doesn't need to be an app on a phone, even though that's very popular these days. It can be some multi-experience. It could be VR, AR, website, iPad, Android, wherever, where it's that interface to your technologies. A big thing is here is you unleash those domain experts, those citizen developers. They have the knowledge, the experience. They don't have the IT background, but they can bring that in. And this is where you get that experience from, let's say, the older, more experienced generation, and then the technology-driven younger generation to really work together and really leverage this. So something that I alluded to earlier is that ecosystem, the support, and the Mendix tribe, as we like to refer to, the Mendix world is actually running parallel with this event. It started yesterday. It's going on a little bit later in the evening, but it's massive. There's a lot of people. Since we acquired, Mendix was an acquisition, they've only grown. If you look at the community, it said 90K. This was in 2019. Then 2020, it grew, or 2021, it grew by almost 100. And the latest numbers that I actually got yesterday, is 250,000 strong. So this is massive. This is the future. If you look at any of the research, if you look at Gartner, Forrester, low-code discipline, everybody should be looking into it. And if you're not, I really recommend that you at least just make sure that you are aware of the value that it could have. So what can be done? And this is not in the future, this isn't a pipe dream, this is something that we're promising to be ready soon. This is now, this is today. And what you can do, so is my screen back? Okay. You can literally go Google Mindsphere for free and click on the first link, and you can sign up. Within, I think it took me 5 to 10 minutes, sign up, get my own little hosting area and onboard my phone. So the sensors on my phone I could see in an IoT type environment. At the same time, you can do the same thing for Mendix. You can Google Mendix sign up, and you can sign into Mendix, where you can start developing that end-use application that's leveraging that data. And the nice thing is, if you Google Siemens Industrial IoT, there's a whole page with all the links, with the whole story what I told you today, where you can go in and see what is this, what are the use cases that's already implemented. We're driving this industrial vertical solutions where there's obviously this platform that we can provide to you, but people need that accelerator where they say, yes, but I'm in the marine industry, for example. So then we have a marine accelerator to help people start off quickly, but then something like low code, it helps you, then you get, let's say, the IP around developing that further and really leveraging so it fits and it can become a bespoke application relevant to your organization. And the last thing, there's no excuse where you can say, no, this is a bit too complex, or have we done this? So a nice almost case study is the Northwest University has this initiative with young women in engineering. And they literally take high school girls. So it's called their HATSI competition, where they take 150 high school girls and they used to present, so they break them up into categories, and then they pick one and then they compete, and first prize gets like a degree sponsored. So it's quite a big competition. And they used to present their final idea in a PowerPoint. But what we've done is we've made Mendix available because you can sign up for free, develop for free. They were able to develop their ideas on Mendix, show it in the competition. And the nice thing is it's possible, there's even a startup program where if this idea really makes sense, you can sign up to the startup program and then take that exactly as it is and actually roll it out into industry. So I went a bit fast, but that's everything from my side. My email address is on the slide. I'm quite active on LinkedIn, so you can just connect there. I connect to everybody. I should probably scan it better, but yeah, open to Q&A. I know I went through this quite quickly, but if you think of something late, if you wake up randomly late at night and think of something, feel free to drop me a note. But yeah, any questions? I'm available till 12, so we can run through this quickly.
Thank you, Hermes, for that insightful presentation. We don't have any questions in the chat at the moment, but I think we'll just give attendees a chance to just enter their questions into the chat box so that we can read it out to our speakers as soon as their presentations end. But before that, we can move on to the next presentation, which is the future of automation, Intelligence and Autonomy by Johann Stein. Johanstein is an artificial intelligence and smart automation thought leader and speaks globally at conferences on the fourth industrial revolution and emerging technologies. In 2019, he was awarded the Best AI and Robotics Management Consultant by Wealth and Finance magazine in the UK. He's a published author who regularly contributes articles on thought leadership to well-known publications such as Business Day, The Sunday Times, FinWeek, IT Web, and Brainstorm magazine. He is the chair of the Special Interest Group on Artificial Intelligence and Robotics with the IITPSA, Institute of Information Technology Professionals of South Africa. He works for PwC South Africa as a lead architect in automation. However, he speaks in his personal capacity. Thank you, Johann. Thank you for joining us this morning.
Vashni, thank you for that warm welcome. Can you see me on screen? That's the first question, and hear me?
We can hear and see you. Thank you.
Super. And next, I'm going to fire up the slides. And I saw with Hermes' presentation, it dropped off now and then. If you can just let me know if you do lose my slides. So let me quickly get back here. And it should be full screen, this first slide. Is that correct?
Correct.
Okay, fantastic. Let me get going. Thank you for this wonderful opportunity. I like the topics that I see on the agenda. I also see that there are 3 Johanns. We always used to joke, remember in the good old days when we actually went to sport and rugby. If you here in Pretoria went to Loftus and somebody shouted Johann, then half the audience would put up their hands. So, but in any case, so as Vashni said, I work for PwC, and they train us to always say, listen, we don't speak on behalf of the firm, which I don't, but I represent the Institute of Information Technology Professionals, as Vashni said, and there I look after the special interest group on artificial intelligence and robotics. And as you see on this slide, a little bit of marketing before I get into the content. I write for Business Day every Wednesday, and a great interest of mine is really the societal impact of this technology. So I write about the techie stuff, but really, when it comes to the future of our children, when it comes to automation, which is a topic of this event, and I want to touch on that as well when we speak about work displacement, unemployment. These are some serious ethical and philosophical, if you would, and societal topics. If we think of where this technology is going, where the biology and the technology are merging, and we are going to start seeing more and more implants in our bodies, which is already a reality, although there are a lot of, I think, ethical and governance and compliance kind of issues around that. But imagine that not only can there be sensors in your brain that can send signals, and again, imagine what that could do from a medical care point of view, but what if signals can be sent to the sensors in your brain and not only read what you think, but also inform what you should think or dictate what you should think? And that often makes me think of Orwell's book, 1984, about the thought police. So imagine you live in North Korea or in Afghanistan at this moment, heavens. So you can always pay lip service to the dictator. But what if in the back of your mind you have different thoughts about the dictator, and the government can pick up on what you think? I'm definitely more an optimist than a pessimist, and I'll touch on the utopian or dystopian future of this technology. But we have to, and this is what I always say when I speak, we have to make sure that we steer this technology in the right direction. To some extent, technology like artificial intelligence is somewhat in its infancy, although it is advancing rapidly, and we are going to get to a stage where we will not have control over it. Do we fear it? Do we? It reminds me when I speak on this topic, I sometimes show 3 pictures, and the one is of the Terminator robot, with smoke coming out of his nose and those evil red eyes. Or I show a picture of a cute little bot that's like a chat bot or a bot that can help you. Or I show a picture, or the third picture I show is just of computer code. And I normally ask the audience which of these pictures best represent artificial intelligence. And almost always the majority of people will say it is the evil robot. And then I would say it's not even the friendly robot, it's essentially just computer code. It's algorithms that we create, it's machines that can self-learn. Whether it will become a cute little bot that can help us think of education, think of healthcare and the like, or whether it'll become the evil robot that will control us and not just take our jobs, but imagine, and it's already a reality when this technology has been weaponized. Think of drones and drone strikes through facial recognition. But then I just come back to, we don't fundamentally fear this technology. We can use it not only for business, which is the topic of my conversation today, but also for societal good. So just a few things I would like to cover in the few minutes that I have is firstly just to talk about where are we on this road of automation. Now, some of the other speakers obviously are going to speak on more industrial kind of automation. I work in the field of software automation, or using software and algorithms to automate business processes and the like. So that's the automation that I'm speaking about. Then I want to talk about briefly the business application of this technology and how it often goes wrong, and what business leaders can do to get it right. Very important topic, workforce planning, because inevitably, as we automate, less and less people will have work to do. So what do we do with those people? Very important topic. And then I just want to briefly talk about, as I mentioned, this utopian or dystopian future. So just a very high level view of, in my view, an opinion, where we are and where I see a lot of organizations are. Now, I work with global organizations and predominantly in the banking financial services space. I'm hearing a lot of pinging in the background, so I don't know if there are questions or if there's anything wrong, but Avashni, I assume if I don't hear from you, everything is still honky-dory and I'm going to keep on going. Just on a side note, as I'm sure you all know, it's the weirdest thing to do virtual conference speaking, because you don't see anyone. You have no idea whether people are responding to it or not. So you just hope for the best. So Vashni, unless I hear from you, I'm going to keep on going. So as I said, just a review of where we are in the evolution of process automation, as you can see on the screen. Now, most organizations that I deal with, and most of the organizations in our market, are still in what I would call basic process automation. So it could be business process optimization and the like. A lot of organizations are already using robotic process automation. And I often say, whoever came up with the name robotic, I would love to speak to that person, because the word in itself generates negativity and fear. Most people, when I speak to them about, what I do, robotics, they still think it's actual industrial robot arms that you see on TV that assembles cars and things like that. And I said, no, it's code that we write in order to actually do, especially the repetitive tasks that people typically do. And the way of explaining robotic process automation as it differs from artificial intelligence, or RPA. RPA is like the hands that do the work. And artificial intelligence is like the brain that does the thinking and the learning. Now think of a business process. Say you get an email that comes in with a client request. Now somebody needs to actually process that email. And the next slide, I'm going to talk a bit about how smart technology can mimic what we as humans do. You see the email, it's a request, say for instance for a quote. You need to go and check in your ERP system, who is this client and what kind of pricing model should you follow, and for instance, is their account up to date? So you start accessing a lot of different systems to try and make sense of what to do with this request. And then you send it for approval, and then the rest of the supply chain process kicks off. A lot of that can already be automated through robotic process automation. We've got the likes of optical character recognition, OCR, but that's also becoming smarter these days, where through machine learning models, it can pick up context. So if you have a fairly neat form, say like a purchase order that's emailed to you, then it's fairly easy to extract the words, especially if it's typed words, from the form, and then actually, so you extract it and you can put it into different systems like your procurement sales system and so forth. But more and more clients are dealing with handwritten forms. And there is so much smart technology that can read handwriting and understand the context. An example I often use, one of my clients, it's a telco, one of their branches in Midrand, they had a customer sign up for a cell phone contract, and all of these contracts are still handwritten. So think of this, say, Vodacom has got like 42 million customers. I mean, MTN, I don't even have the number. Well, that's in South Africa, and then in Africa and overseas, MTN is even bigger. But I'd imagine the amount of paperwork being generated by your telcos, or by your banks for that matter. I mean, if you've done a loan application recently or a bond application, it's a heck of a lot of paperwork. It needs to be scanned and stored. But rather than people recapturing that data, and that's where errors come in, you can actually read that data from a context point of view. Now, this mobile phone company had a branch in Midrand, but the handwriting seemed like midfields. But because there's context now in this form, and because the system can learn and understand context, it recognized that this contract was signed in the Midrand branch. So it then decided to extract this text as Midrand and not midfields. So that's where the technology is at the moment, but it's still fairly in its infancy. So that's what you see on this slide. Fairly basic automation replicating human keystrokes. Some organizations, some of our big banks and telcos or insurers are already in this next step, which is now predictive, to interpret the information and make judgments. And we're going to eventually get to autonomy, but we already see elements of autonomy throughout this evolution. In other words, humans are not necessarily in the loop. Humans do not have to make decisions. And another example I want to use there, a client of mine is one of our big banks, and I don't know if you'll believe the story. I almost didn't when they told me. Every morning, their staff, and they say about 40, maybe 50,000 staff, have to fill in a little Excel questionnaire, which is a COVID questionnaire. You know, we know what it is. It's do you have a sore throat and a high temperature, etc., etc. They fill in that little Excel sheet and then they attach and email it to their line manager. Now imagine 50,000 people doing that every day. There's no way that those line managers are inclined to or able to process all that information. It doesn't make sense. You cannot see trends in this data. So what we would rather do is create a browser or a mobile phone little application that makes it easy for people to every day capture their information. But then all that data is collated and can be analyzed. And this is where the autonomy come in. So as an example, so say the staff at a specific branch, say Boksburg or wherever, start indicating that they are feeling sick, that their temperatures have been going up, that their throats are sore. Now, there's no way we could do this with 50,000 emails every day, but through an application collecting the data we can. Now we can start looking at trends and patterns, and that's what smart technology can do. When we talk about big data, another example is, our telcos have about between 700 and 800 different data points on each of us. Your telco provider knows more about you than any other person or any other provider in the world, because they know exactly where you are, call it geospatial data. They know what applications you use, what data you use. They pretty much know when you get up, when you go to bed, and so forth. So imagine what you can do with all that data. And that's why we have things like POPI or POPIA, the privacy legislation in South Africa, or GDPR overseas, because we are willingly giving up more and more data. But just back to this COVID test in the bank. So now you're picking up through the pattern that staff at a specific branch are most probably going to have a COVID problem. In the past, a human will look at that analysis and then call the branch manager and say, listen, there's a problem there. Maybe ask your staff to stay at home while we investigate. We need to sanitize the building. But humans don't have to be in the loop necessarily. We can create an algorithm that says, looking at these patterns and on these perimeters, we can actually automatically send a notification to the affected staff and say, we want you to stay at home for the next few days while we investigate. That's just one little example. But there's so much autonomy and automation and decision-making that we are starting to see. And then the next step is cognition, and this is really where the machine learning and the pattern recognition comes in, where the processes are almost managed and even created autonomously. Very few companies, if any, that I can think of in South Africa in particular, are there already. And then the last step, which is not reality yet, because here we need what they call artificial general intelligence. We're currently in what they call artificial narrow intelligence, which means it can, to some extent, mimic the way we think and make decisions. And thinkers have various opinions. Are we going to be there in the next 5 years or 50 years? But once artificial intelligence technology grows to be exponentially smarter than human and human reasoning, we'll only then get to this autonomous world. And this is where we're going to start seeing problems. Nick Bostrom, for instance, is a professor at Oxford. He writes about us creating the so-called useless class. And it's kind of going to be in one of my later slides, but let me touch on that quickly. What Nick Bostrom is saying is that we're going to see more and more of a technological apartheid, if you would, where only the rich and famous will have access to incredible technology. And again, back to the implants, and think of increased longevity, think of the eradication potentially of cancer and other illnesses. But most people will not have access to that, and most people will not have work. And if you're whether you're blue or white collar work, and especially, if you're a knowledge worker, think of this: anything you do that can be repeated as part of your job can be automated. Now, things like empathy and leadership and all those other things, will computers be able to mimic that? We don't know. I think it will be possible in the future, but so there's still an element of us working together as humans that cannot be automated. But no one should think that their jobs are perpetually safe. We should, and again, not living in fear, but we should be smart about how we upskill ourselves. And you might say, but I don't work in technology. It's still going to affect your life. Now, you don't have to become a computer scientist or a algorithm engineer or an artificial intelligence engineer or data scientist or any of those things. But whatever work you do, and especially as a knowledge worker, you have to be aware of how this technology is going to impact your work and almost stay ahead of that curve to make sure that you will have a job into the future. And this brings us to education. I mean, if you're going to varsity right now to study to be, I don't know, a doctor or a chartered accountant or whatever, by the chance you graduate in 3 or 7 years from now, there's a chance you will already be redundant. Because even our tertiary institutions, and this is a worldwide problem, are not preparing our workers for tomorrow. One of the reasons is because we can't quite imagine what kind of jobs we will have in the future. My son is 7, and grade 1, happy, playing around and stuff, but I constantly think about, what job is he going to do one day? Do we send him to university one day? It's a question I think we should be grappling with. Just to move on, just some of the things that computers can already do that humans do. The first thing is we see. Remember I said in an example, an email comes in or a request comes in and you look at it and you have to decide what to do. Computers can already recognize it. I referenced optical character recognition. Think of self-driving cars that need to be able to see the road, see road signs, see pedestrians that cross the road. That technology already exists. Then we take what we see and we have to make decisions and execute work. This is where robotics process automation comes in as a good example, even though it's on the lower scale of where this technology already is. Anything that, so now you see the purchase order come in, we need to decide what to do with it and we need to action. That can already be done. Language is where we see, I mean, if you have a smartphone, you can easily have what you say be translated or just typed, they call it natural language processing, and it's super accurate. Some of you might remember a few years ago, you had products like, I think it was called Dragon Dictate. And you had to spend hours training the software about your particular way of speaking, your particular accent. I mean, right now, for a good example, if you open Google Docs in your Chrome browser, there's the option of actually dictating and it will pick up your voice. It's not 100% accurate, but I must tell you, it is amazingly accurate. Of concern to us is, what do we do with native languages? There are about 2,000 to 3,000 languages in Africa. How do we serve those clients? Because most of these platforms are American, Canadian, or European. And how do we pick up the nuances between the way different people speak when it comes to what we these days call not chatbots, but conversational artificial intelligence? We already have call centers that you can speak to what you think is a human being, but it's not. And it can show empathy, it's got ums and ahs, and it'll also pick up your persona. If you're a young, hip kind of a person or an older investor, it will speak to you in different ways. That technology already exists. And then the last thing that we do when we work is we learn. We recognize patterns. We might do something like this today, and then we learn we can do it better in another way, and we keep on learning. The same is true of this technology. It can keep on learning to do things better and better, based on past experiences, past patterns, and the like. Briefly want to touch just on what do we do when we implement technology like this. And these are such common sense things, but working in the tech space, I find that now myself, not super duper technical, but I work with some, and I always have worked with some exceptionally smart people. I always joke and say, I don't ever want to take them to the first few client meetings, because they will already start looking, and I always mess this up. What's that saying of, you've got a nail and a hammer, so you're looking for, or you've got a hammer, you're looking for a nail to hit, or something like that. We hung up on our technology and we want to fix The problem without understanding it with the technology, and I often, when I speak to clients about robotics or artificial intelligence, because they'll call me and say, come and talk to us about how we implement AI in our HR department, for instance. And I always start the meeting with saying, to do what? In your mind, what is this technology? Or what do you think it can do? And much more often than not, they can do what they think they should do with the technology they already have. It is often just re-engineering or understanding their processes and things like that. This is not a silver bullet. It won't fix fundamental ways of working, silos, culture, and those kind of things. Just to quickly go through some of the icons here on the screen. And again, it's such common sense. And whether we talk about smart automation or AI or anything else, align it to your business strategy. It should support the strategy rather than the other way around. What I often find when I deal with clients is they have some sort of a bright idea to use artificial intelligence. Sometimes they mandate it. The chief information officer went to visit Silicon Valley and he or she was taken to Google and Facebook and the like. Now they come back and say, we need to make sure that we are like Google. I had this before when I worked at the bank. It was a bank that was 117 years old, one of our local banks. Massive organization, and hence a lot of politics, a lot of structures, very siloed, federated. And the chief information officer came back from Google, and their idea was to make us more Google-like. Now, if you're a startup and you've got very little legacy systems or legacy cultural and political issues, that's much easier. But you can't just take the Google or Spotify, for those of you who use Spotify, that model, and just slap it on top of a big, massive old organizations, old ways of thinking and the like. So you have to align it to your business strategy. Your strategy might be, we want to lower our costs with 10% over the next year. Okay, now we can look at how technology can do it. You might say we want to respond to our clients 50% faster than we are doing now. We want to take all our client interactions, look at the patterns, and see if we can develop new products and services that we currently don't offer them, but they want to buy it from us. Then this icon about people. All technology initiatives, I always say, should be a people-first initiative supported by a platform, not the other way around. We start automating without taking our people into account. Here we talk about target operating model redesign. We're talking about change management. Again, people fear it, they resist it. Any sniff they get that this automation might impact my job, they will resist it. But if you do it right, if you pull your frontline staff, and for that matter, key customers into the conversation, and they can see how automation is going to make their jobs easier, more enjoyable, no more 10 o'clock on a Sunday night writing a report for the Monday 8 o'clock meeting and those things. Then you start getting that cadence and you start getting people on board. Look at the history of previous automation initiatives, because mistakes were made for very specific reasons, and make sure you take those mistakes into account and don't repeat them. And that could be that it was your automation in the wrong area of the business, in the wrong way, the change management that I just referenced and the like. And then how can people who've already been through some automation initiatives and almost have a bad taste in their mouth now, and they almost look at you and say, see, I told you that's gonna fail. And the previous 3 guys or girls who were here who tried to automate, they all failed. Keep that in mind and bring that into your change management plan. And then maybe one of the biggest parts of this whole journey is your data. A lot of organizations have a heck of a lot of data on their clients, on their back office operations and the like, but it's often unstructured. It's often all over the show. I mean, I've worked with some big clients where some of their key client information was on a USB thumb drive in somebody's drawer. Again, now with Popea and those things, that is a massive problem. But you have to look at your data strategy. What information are we currently getting, or do we have from our clients? What information don't we have but we need? And what are we going to do with that data to quickly interpret it? We already have technology platforms, and some of these vendors are in South Africa, startups who work on human behavioral science. So they can, within a few seconds of a client interacting with you, especially in the digital channel, they can within a few seconds predict things like churn, whether the client is happy or not. You get things that like sentiment analysis through the way they chat in the chatbot, or even through their voice. So if And as an example, before I move on, when that voice chat's happening to your call center agent, be it a person or a bot, you can pick up in the sentiment analysis signs of frustration, for instance. And then you can look at your data. I mean, if this is a very important client that spends a lot of money with you, and you pick up certain levels of frustration, maybe you should automatically route that call then to a senior person in your organization. So the business case and the variables around this and using this technology is almost endless. I've already touched on people first, but this is a big thing that organizations grapple with, especially when we speak about automation. What do we do with all our people? Because inevitably, as we automate, more and more people, especially back office staff, doing repetitive kind of work, will no longer be needed. I have this policy. Whenever a client talks to me about what we call FTE reduction or full-time equivalent, which is just a smart word for human beings, but I want to automate to get rid of my people or some of my people, as a rule, I walk away, because getting rid of people is not a good enough reason to automate. And then I use an example. I say currently you have 100 people, but through automation, you actually only need 80, so you can get rid of the 20. And then I say, but are you not planning to grow into the future? So let's turn this conversation around from cutting heads or headcount to future planning. So now we say you've got 100 people, you might grow to 120 over the next year or two. Let's keep it to only 100 as you have at the moment, but through making their jobs easier, through automating some of their tasks, and through upskilling them, you keep the 100. And there is the business case, not needing 120 rather than just cutting headcount. And I've got a minute and a half left. So this is essentially my last slide before I'll briefly look at if there are any questions. I alluded to this in the beginning. What kind of future are we creating? Utopia or dystopia? Utopia will be an incredible future. And if you read about this, there are so many different views. If you look at futurists and what they write in particular, from a utopian point of view, we can create a very equal society. We can create, as I mentioned, longevity, much better healthcare, preemptive healthcare, and not just treating you when you're already sick. And the example I use is my son. What if he can get an implant that can track him wherever he goes? There are two sides of the coin. In South Africa, as shocking as it is, 1 out of 4 people will be a victim of human trafficking. And all parents will agree with me. The one thing, I would rather stand at his grave than him go missing and I'll never see him again. But if the chip implant can track him wherever he is and we can go rescue him, absolutely. What if the implant can pick up the development of cancer cells long time before a doctor would diagnose it so we can treat him? Then the dark side is privacy. Well, again, like what if that implant can read what you think? What if there's no more privacy? Because our thoughts are our most private thing that we have. What if that is no longer private? So this technology can go very utopian. And as I say, I'm an optimist, but I think looking at human nature, because we are very tribal, very selfish. One of my favorite quotes, and I can't remember the author, he said, in every civilized person, there is a pagan waiting to come out. And I think we all know that if we press the right buttons with people, think of natural disasters and what happens with pillaging and stuff. So there's a good chance we're going to mess this up and we're going to send this technology in the wrong direction. But, I've just briefly touched on a number of things. So where's the technology going? What is possible with this technology? How to smartly implement it in your organization, taking your people on the journey with you, and then working together to create a better future for us and our children and our communities, rather than creating a bad future. And with that, Vashni, I'm going to stop sharing, and I would be very surprised if there's no one here anymore and I've been cut off without knowing it.
Thank you so much for that, Johann. Yes, the first Johann of the day. Thank you very much. And thank you for, I think, just bringing about some discussion points that I'm sure everyone has debated previously in terms of, will robots take over the world? And also, what part does AI actually play in terms of judgment? Can it replicate human thinking and judgment? So I think those are big topic and debate discussions as well. I'm sure your campsite talks are quite interesting
with whiskey.
with those discussions. And I think also you alluded to a very interesting thing. So tomorrow on our program, we also have cobots talking about whether robotics will actually take over jobs and where does it fit in terms of also assisting with that job creation. You know, is a robots the future of jobs, or is it something to be explored? So thank you for that. We don't seem to have any questions, but if you don't mind just putting your details into the chat, so if anyone wants to contact you directly, they can do so.
Thank you.
And next up, we have Johann Hermann from Dessoft, who's been waiting patiently in the background. Johann is involved for the past 20 years in developing software solutions for engineering documentation regarding the instrumentation, electrical, and process disciplines. Documentation like asset lists, specification sheets, wiring diagrams, P and ID diagrams, equipment lists, etc., where the software is used by engineering, construction, and procurement companies, as well as, and he is as well the owner operators to create and maintain those documents within the different mining, diamonds, platinum, gold, metals, coal, as well as the chemical, nuclear, food sectors. So Johann, it's a pleasure to have you this afternoon, and over to you.
Sorry. Thank you. So thank you, Rashni. It's a pleasure to be here. Thank you for the invitation. Great opportunity, and it is appreciated. So I would rather start with my presentation and then share my ideas as well with you guys. So just starting it. Can you see my screen? No, not yet. And let me just start this again. Okay.
Yes, we got it.
Excellent. So thank you. So as Rashni already mentioned, Dessoft is providing software for the past 20 years in the engineering environment. And it's about design documentation, but I'm not going to talk about our software. I'm going to talk about having the correct starting point for your digital information. So digital information, as we see it in the industrial world, is not new. It is there since the 1980s already, and some of that even earlier. And there are many different platforms and many different requirements for digital information. Just to mention a few is that information for the office administration part, we know all the Microsoft products. When they are for procurement, different systems required. We all know about plant control and plant monitoring systems, and many of these guys are with the automation fair. There's conditioning monitoring, then engineering design, where we fit in as well. There are the 3D and 2D environments, different documentation that you have for different departments. And then you've got your asset management systems, and I can carry on. So there are multiple environments, multiple platforms that you need digital information nowadays. So the challenges then that we see within our digital environment is we have known for many years already that any software system is as good as the data that's inserted into the software. So the old saying, garbage in is garbage out. Then another thing is, if I got too much information, digital information, it's also overwhelming. Where do I start? What is important? What must I ignore? Where's the focus going to be? So too much information can't work as well. And then the big challenges nowadays is which software is the best choice for the job? So for the platform that I require this information for. And then the other challenge is if I'm using different vendors and different systems, how do I integrate my information between them? And to top this, nowadays, you also want to ask the question, must my information be on the cloud or on-premise? So you can see many challenges, many questions, many things to consider to having good information and your digital information available. So the solution is, unfortunately, I don't have a solution for you, otherwise I wouldn't be sitting here. But there's unfortunately no simple answer for the digital information and also no one-stop solution to these challenges. We found that, like if you talk about office administration, Microsoft is dominating that world. Then you have the IBMs with storage capacities and systems. We have many engineering companies that can handle industrial engineering, PLCs and SCADA systems and so forth. But what I'm going to do today is maybe focus on a topic that I think many people overlook, and that is your majority engineering documentation during your plant design and then your plant maintenance afterwards. And I also assume that many of the people that's always attending the automation fair are aware of these documents, are aware of these challenges, and is familiar with these types of documents. So to start with that, I've come across a big issue in the industry, not a big issue, but I think a misunderstanding maybe, and that is your engineering cost versus engineering documents. We found that when you build a plant, then the 80% of the cost, your engineering cost, is within your civil, mechanical, and process environment. And 20% of the cost of your building the plant is for electrical and instrumentation and control departments. But when it comes to the engineering documents that you provide to build this plant, then suddenly there's only 20% of all the documents, engineering documents, comes from the civil, mechanical, and process departments, and 80% of the documents from the electrical and instrumentation and control departments. And you will see a bit later in my presentation why this is happening. But it's good to understand it, because what's happened is, what we found is the guys with the biggest budget, in other words, the civil mechanical guys, the guys that's building the building, all the tanks, all the processes, they got the biggest budget, and very often they make the decision what type of software to use for all the engineering documents, not understanding necessarily what is happening, for instance, in instrumentation and control world. And that's my first, or the previous slide, where I said there's no one-stop solution for all the different departments, and that is what you need to consider if you want to have a good system, good digital information to all departments in your company. The other thing that we are talking about nowadays is we hear a lot about the digital twin and your plant and asset management and so on. So when I talk and hear from the guys that are specialists in your PLC or DCS systems, your SCADA, enterprise asset management, digital twin and simulation, IoT, then yes, they can talk very lengthily about each of these systems and what they can do and what the benefits of that are. But when you ask them, where do you start? How can I start with my PLC program or my SCADA system or my digital twin? Then that comes back to the granular details of your plant, those details that we can deliver from our desktop applications. So I'm just going to go a little bit into that, because again, that is that 80% of documents that nobody is aware of in your plant environment. Not nobody, but a lot of people overlook that. So what are the granular details then in a plant? So if we look at the starting process of any design, they will start with a process flow diagram in a process plant. So on a process flow diagram or a PFD, you will have your mechanical equipment like your tanks, reactors, vessels, etc. And then you will have your process stream information. What type of processes are running in this plant? So water, steam, chemicals, gases, that's in there. And then that PFD will become a PNID, which is your piping instrumentation diagram. And suddenly you add to the document process pipes. And the pipes inherits the stream information already mentioned. And then you add electrical motors to this document that will drive your pumps, your agitators, and other mechanical devices. And then you add your control to it. So for instance, you add your tank, you need to have an inlet valve, an outlet valve, a level sensor for that tank. Your reactors will have pressure transmitter, your pipes need flow control inside it, and so on. So you suddenly see how many control devices are added to this plant environment. And if you think of an average plant in South Africa, it's between 3,000 and 5,000 instruments that's inside that plant. Your bigger plants is up to 20,000 and even more. So a lot of instruments, and each instrument have a cable that tells this, takes its signal to the PLC or the controlling device. So then at least there's 5,000 cables, and every cable got 3 cores, and those cores need to be terminated. So now you can see where the granular details comes from and how easily it adds up to lots of documents. So the documents that's been created then for these equipment during this process, and I mentioned documents because that's your digital information that exists. Now, the difference is if you can make that intelligent, then it makes a huge difference in the whole way that you can approach your plant environment. So already mentioned for process, you have your PFD and PNID diagrams, and then you look at the electrical side. So the moment you add that motor, what you also need to realize is that there's a motor control center. And inside your motor control center, each motor inside the plant, you need to know how that is wired inside the what we call the cubicle. So you will have single line diagrams, you will have schematic diagrams within the MCC, you have a general arrangement how to bolt your MCC to the best you can, will fit for the loads. And then you have further granular details. So you will have a motor list with the manufacturer model of that motor, the load capacity, the RPMs of it, and so on. You will have a cable list for each of those motors, cable that come from the MCC to the motor, what type of cable, what is the manufacturer again. And then you will have your electrical devices like your circuit breaker, your isolators, and your contactors. You want to calculate the cost of all of these. And you can see how many times a piece of equipment is replicated in all these documents. So that detail that I'm talking about. And now again, the same thing applies for your instrumentation world. So you will have, for instance, there a cable block diagram that gives you an overview of all your cable connections within your plant. As I said, if you just think of an average plant in South Africa, it's 5,000 instruments with 5,000 plus cables just for each instrument because it needs power, it needs signals. And then when you look at the termination of these, you have a loop connection diagram that can do your commissioning and your fault finding from the instrument, how it's connected to a junction box and a termination inside your panel. And then that same instrument is also connected to a PLC card on a specific channel or a specific terminals. These are panel termination wiring diagrams for construction purposes to easily bolt those panels and wire that correctly. So not only to wire it, if you think of that, it is at least 3 times cores for each cable. So you're talking about 15,000 cores and terminals that needs to be documented, it needs to be marked, and then the guys can construct that. Again, you need an instrument list that can do your give you instrument details, what type of instrument it is, the manufacturer model of it, the cable, where's the cable coming from, where's it going to, what type of cable is an 8-pair, a 2-pair cable, and so on. And the IO list is where this instrument is associated and the soft address of that connected to that PLC. And again, the costing of it. So what you see on top of that is also data sheets or specification sheets that you need for all these equipment. Again, for instrumentation, we just say 5,000 things for all the motors, for the tanks, for the pipes, for the cables. You can see how many of these digital information and documents you require in your engineering world that's been used. So that really creates a lot of data that you need to manage. So a solution that we offered from Desktop is that we have an integrated solution and one database. So one source of the truth between your PIN-ID, your electrical, and your instrumentation world. So for instance, if you work on a motor on your PIN-ID, you can see on that PIN-ID the properties of that motor. You can see the load, the manufacturer, the model. You can see the RPMs, the absorbed power of it. And you can see that also in the electrical side, and you can add more to that without cluttering your documentation, and that's a huge benefit. The same applies for your control valve, for instance, or a flow valve. On your PIN-ID, you can see this flow valve. You can see again the line size and so everything about that valve. But the instrument guys can see that as well, and it shares, and you can share data sheets between that. So suddenly, if there's a change, and say, and we know within a design environment, the tag number, for instance, can change sometimes or very often. And just by changing it on your PIN-ID, in our case, it will also replicate that same change to, say, for instance, it was the valve on your loop drawing for that valve, on a termination drawings in the panels, on an I/O schedule to the PLC, on your instrument list and your cable list. So you can see how many times the same source of information is duplicated on multiple documents. Now, if you have a manual electronic system, which is also digital, then unfortunately it doesn't give you this capability of automated updates of all these documents. And that is where the problem starts. So if, for instance, if you have Excel running with all your lists and you have other drawing system that can open drawings and update that, it means that you will have to open each of these drawings one by one and update these tag numbers. And this is where the problem starts at. When you are interrupted, maybe you forgot to do one of these diagrams and suddenly you are out of sync of what's happening with reality in a plant and on your documentation side. So with having an intelligent system that can automate all of these for you, you suddenly have accurate information in your data. You also eliminate duplication of equipment. In other words, we find that the different departments kept their own list or have it in silos. In other words, they have their own list that they maintain. And sometimes there's a change of equipment, and then the other department is not aware of that. And then you get redundancy that crept in, and so on. So if you have your data sheets, you really have now good information. And this information, if you carry it over to the end user in the end, the owner operator, then it preserves valuable information from the design phase to the maintenance phase that you can give to your clients. So if you look at the asset list, it creates an accurate asset list for you. And this time with proper asset information, you know everything about that piece of equipment. So now you have a good starting point of digital information that you can provide to these other systems, as already mentioned in the previous slide. The other question that you come to is, how do I maintain then all these diagrams? So if you think of all these documents that I mentioned, for 5,000 instruments, for instance, you have maybe 3,000 or 4,000 loop drawings, you have 5,000 data sheets, you have your instrument list, and I need to maintain that. Now, we have an intelligent redline system that you can use within our applications and on our viewers, and it will flag the database about this change. But what it also will do is it will create a workflow. So a workflow is where you can select a change procedure that you can associate with other responsible people that need to know about it. And maybe before I go further, I just want to interrupt myself here. You know, if you think of changes, there are well-planned changes that you can do when you do plant extension or upgrades and so on, or big modifications. And with this well-planned changes, there's a shutdown and everybody is prepared and is pre-approved and the whole system goes on. So that is fine and it works perfectly for everybody. But what I found, especially in an instrumentation world, is that because instruments are a lot more vulnerable to the plant environment than the other equipment, just because of its sensitivity and the way that it's constructed. And very often it's also the process environment itself can damage an instrument, or it can't last that long. Or even when you do like moving equipment within the plant itself with other bigger vehicles, it can happen that it damage one of your instruments or more, or through a cleaning process, or whatever case can be. And so what we found is with the instrumentation world, there are a lot of ad hoc changes happening in your instrumentation world. And these ad hoc changes are difficult to maintain, and this is where our change control workflow is coming into place with the intelligent redlining. So how do I manage these ad hoc changes that's not well planned beforehand? Because the guy get called out over the weekend, and then he read, if he doesn't find the documents, then sometimes this is never even monitored at any point. But if you can have your documents available within your control room and the person can immediately do a red line there, then, and it can activate a workflow. And now it comes to the change procedure that you can select. You can have one for process, for electrical instrumentation, and more. And with the change procedure for instrumentation, you can say that the engineer must be notified, the supervisor, the technician, and so on. And suddenly there are means to either approve this change, although it was done overnight, or you can go and rectify it the next time you've got an opportunity to make sure that's within your engineering and safety standards. So suddenly you have a way to maintain and have a history of all your changes, and this can help you to maintain your plant better. So to conclude then, if I look at my plant or a manufacturing environment, and if you have good quality starting information that can be easily maintained, then suddenly your digital information can really help you to make your plant running a lot more cost effective, because you can reduce your plant downtime if you have information available. The simple thing that I always use is that if you need a fuse has been blown on a control valve, if you don't have trusted documents, people will just do cable tracing to find that fuse. But now if you trust your documentation, you can quickly see and you can have quick access to your information. Then you can see the fuse and you save maybe 10 minutes downtime on this occasion. So if you add up all these 10 minutes over a year period, imagine how many downtime hours you can save. And obviously that can benefit your bottom line. So, and it also helps you to maintain your systems better, your documentation better. It also helps to make your people more effective. So they have quick access to information, they can make better decisions. And even if they move between sites, they can adapt much more easily when they get to the new site, because everything is familiar and they are familiar with those systems. So yes, Desktop then really can provide you with a system that can create these granular details for all your other nice systems, for your asset management, for your PLC, for your digital twin, all these systems. And it is really the first step of good information that you can use with quality information behind it. And then with our workflow, really be able to maintain these documents and the information behind it, so that you can always be up to date with your information. So thank you so much for listening to this, and hopefully it gives you some insight of where to start with good digital information. And also to the Automation Fair, thank you for this opportunity, and you're welcome to ask some questions.
Thank you so much, Johann. Thank you for that insightful presentation. And also, we enjoyed having you on this afternoon. There doesn't seem to be any questions at this stage. I wanted to find out if you can just leave your details in the chat And if anyone wants to get a hold of you directly, they can do so. Without wasting much time, we can then move on to Johann Martens from SAIMC. Johann is the director and CEO at SAIMC. He studied at the Northwest University and obtained a BSc and BSc for electrical engineering. He has worked for Sasol as an instrument manager, Mogas as an IT manager, and at Siemens as a senior MES project manager. He became the president of SAIMC in 2011 and is now the director and CEO. He was part of the team who defined the discipline of specific training guidelines for factory automation, process automation, and mechatronic devices for ICSA within the mechatronics engineering discipline. He also trained as an assessor by ICSA to participate in assessing the practical experience of candidates who apply for professional registration, and he is was the chairman of MBW Motorcycle Club in Pretoria and a scuba diving instructor. That's quite interesting, Johann. And this afternoon, he's going to talk to us about CPD accreditation. Over to you, Johann.
Thank you very much, Vashini. I'm going to share my screen quickly. There you go. Thank you very much for the opportunity to participate amongst all the other Johans that were here this morning and talk a little bit about continuous professional development and what the changes that happened in the last couple of weeks from March 2021. I'm going to go through this agenda very quickly so that I can get to the CPD portion, but there's some background that I quickly want to cover. We've been talking about this since 2011 when I became president, so I'm not going to spend too much time on this portion of it. So the background is the Council for Built Environment Act number 43 of 2000 and the Engineering Professions Act number 46 of 2000. Now these two acts, the CBE Act of 43 says that they needed to create identification of work. They need to come up with recommendations and specify what actually engineering work entails. If I talk about engineering work, I'm talking about technicians, technologists, and engineers. But because I don't want to have this long sentence, I'll just talk about engineering work. And then they had to determine a policy regarding this, consult everybody, and this consultation process for the identification of engineering work started in 2000, and it was only completed in March 2021. So it took 21 years for this to go through the whole consultation process, spanning various governments, etc. So then we go on to the Engineering Professions Act. Now this Engineering Professions Act was also promulgated in 2000, and it says a person may not practice in any of the categories unless he or she is registered in that category. That category is technician, technologist, and engineer. Now, what was interesting is that although the Act says they were not allowed to practice in those fields, the engineering work was never defined. It took 21 years to define it. So people later thought, this is just smoke and mirrors, it'll never be defined. And then 20 years later, suddenly one morning we get the email, here's the government gazette, it's now here. So now what happens if a person who's not registered does engineering work? Well, they can be fined equal to double the remuneration received while doing that work. This is not a fine to the company, this is a fine to the individual who's doing the work. So now the identification of engineering work was finally gazetted, and we need to look at what is this engineering work they're talking about, because we get various people calling themselves engineers, and everybody thinks that engineering work is something different. And so when I talk about engineering work, I'm talking about the definition that was created and established by the voluntary associations together with EXA. And I'm not going to read through this, it's just a process of applying engineering and scientific principles. Now, to define the difference between what a technician and a technologist and an engineer does is quite difficult. And you can imagine why it took so long to do these distinctions, because technicians feel they can do engineers' work, and engineers feel they can do technologists' work, and technologists feel they can do everybody's work, etc., etc. So it became very difficult to create this distinction. Well, technicians, they do work that is specified as well-defined engineering problems, like it can be solved mainly by practical engineering knowledge, underpinned by related theory, is largely defined, but it may require clarification, involves several issues with conflicting constraints, and it's a limited range of interested and affected parties. So this is a broad definition of technicians' work. If we now look at technologists, this is now broadly defined. And broadly defined means it's ill-posed, under or overspecified, requiring identification and interpretation into the technology area. It involves various issues with conflicting constraints and has significant consequences which are important in a practice area but may extend more widely. If we now look at engineers, this is described as complex problems. Complex, what does that mean? It requires in-depth fundamental and specialized engineering knowledge with unfamiliar encountered issues. Its solution is not obvious and requires originality or analysis based on fundamentals, often outside the scope of standards and codes. So now, who has to register? I'm going to now go into some of the examples of work that is done that is classified as engineering work, and you are really encouraged to go to the EXA website and go and download this identification of engineering work. It's also on the SMC website to go into more detail. I'm just skimming through some of the stuff. So as far as electronic engineering is concerned, it advises and designs electronic devices or components, circuits, semiconductors, and systems, specifying production or installation methods, materials and quality standards, directing production or installation of work, and supervising, controlling, developing, monitoring the operation of maintenance of electronic equipment and systems, and then establishing control standards and procedures, organizing and directing maintenance, so even the maintenance people are involved here, and this designing, specifying, and implementing control and instrumentation of plant and processes. So there's no uncertainty as to whether the instrumentation and control people, the work that they do, fall under engineering work. And then, of course, robotics and process control of a manufacturing plant. There are some more examples, but now I'm moving more over to the computer and software engineering portion of it, advising on and designing computer-based systems or component system equipment, software and distribution centers. Now, if I talk about designing, I just want to make a quick statement here, and that is design is in different levels. You get designs on a technician level, design on a technologist level, and design on a complex level. So if you have a big OEM company designing brand new systems, that often falls in the part of the engineers, where designing of control systems in a plant where equipment is already running mostly falls under technician or technologist, and sometimes under engineer as well. So supervising, controlling, developing, and monitoring the operation of maintenance of computer-based systems, software, networks, and equipment. Organizing and directing maintenance and repair of existing computer-based systems, programs, and equipment. Planning and designing computer-based communication networks. And this can be fiber, it can be wireless, it can be ultra-high-speed data networks, it can be any type of computer-based communications. And determining manufacturing methods of computer-based systems, as well as the maintenance and repair of existing computer-based systems, networks, and equipment. So you can see this is quite a broad spectrum of people that are actually doing engineering work. And I must just reaffirm that when I talk about they're doing engineering work, it doesn't mean that they're all people sitting in a dark room with thick glasses and designing revolutionary control systems. I'm talking about even the people who are on the plant busy maintaining their equipment. Now, the purpose of CPD is to remain globally competitive and maintain a high standard of engineering. Now, this CPD was not developed by EXA to keep themselves busy. This was designed by engineers saying that engineering is one of the fastest moving fields in the world, and people are under the impression that once they have achieved their diploma or their degree, that they now know everything about, there is to know about control instrumentation, mechatronics, etc. And we all know that's not the case, especially people who have been in the field for a while. They know how quickly things change. It has become necessary for engineering practitioners to maintain their engineering knowledge and skills, like their overseas counterparts, in a more formal, structured way. Now, this CPD is not only relevant to the latest and greatest technical advances. It's many engineers are also involved in management, and it's also management skills, and that type of stuff is all part of CPD. Why introduce CPD? As I said, because technology advances so quickly, and need to regularly update the knowledge. And it's also necessary for EXA to maintain international recognition. If you're registered with EXA, you fall under either the Washington Accord, the Dublin Accord, or the Sydney Accord, which is a worldwide recognized body. Now I'm going to quickly look at the CPD itself. And it runs in a 5-year cycle for those that don't know it yet. And it commences on the date that appears on the certificate of registration that you can see on the EXA website if you want to know when you're registered. This date is available on the website. You can just go there to find out who's registered. During a 5-year cycle, they need to obtain 25 points, and it needs to be obtained in all 3 categories. That's category 1, 2, and 3, which I'll discuss this now. And not less than 3 credits per annum and at least 2 of the activities. And you have to have points, at least 1 point in each of the categories. Now, there are transitional provisions, because now, as of today, it is possible to find people that are doing engineering work that is not registered. But they made a transitional provision in the government gazette saying a person who requires to be registered, if the surname starts between A to K, they can start applying from the 1st of January to the end of the year. And then letters L to Q may apply for registration from 1 January 2023 until the end of the year. And R to Z is from 1 January 24 to that December. Now, one thing that I need to explain here, and that is that the people who does the assessments for registration, they are not EXA employees. They are people in industry who are already registered that does the assessments. Now, so there are not so many of us that that everybody can wait until 2024 and then start registering, because you cannot pull so many professionals out of industry to come and do the assessment. So if a person that starts between A and K does not register in 2022, but only tries to register in 2023, the chances are pretty good that there will not be enough people available to do that person's assessment, and they'll have to wait until 2025. The disadvantage of such a person will be that during 2025, while they are not registered, they will have to work under a registered person. These are the categories. Category 1, this is your CPD. Category 1, you need 4, maximum per annum is 4 credits, it's 40 hours. Then category 2 is the work that people do and mentoring of candidate practitioners. Category 3, that is individual activities. And what the SIMC has done is we are going to, the technical evenings will fall under category 3, because category 1, as you'll see this now, has got a lot of additional requirements that have been added. Category 3 will have the technical evenings where people can attend a technical evening. They have got 5 multiple choice questions that they need to answer. If they obtain more than 80%, they'll get a certificate automatically downloaded, and they can upload the certificate to EXO's website to provide evidence that they did some self-study in category 3. Now let's look at category 1, that's the formal development. At least 5 credits must be obtained within a 5-year cycle in category 1. A maximum of 4 credits per annum, and a full day is what it actually works out 0.1 point for an hour, 0.5 for half a day, and 1 credit for a full day. Now, aspects that need to be covered, it can be maintained, and it must maintain or enhance the knowledge, skills, and competence of participants. Meet an educational and development need, and provide an effective learning experience. Participants must be specified, whether it's professional engineers, technologists, certified engineers, and etc. That needs to be specified. Okay, now the depth and breadth of the subject matter covered must be appropriate with sufficient time for discussion. The subject covered should provide a balanced view and should not be unduly promotional. Just a word of warning here, if a subject is of such a format that you can actually read that information from a sales brochure, that will not be accepted as a CPD activity. It needs to take that, what's in the sales brochure, give some practical examples where it should use, when it should not be used, some examples of where it was implemented, cost applications, things like that. The presenter should have proven practical and academic experience and be good communicators. Evaluation forms for obtaining feedback from participants on the activity must be provided. So in the past, 2 months ago, you could have the CPD activity after SIMC approved it, and it was not necessary for you to send evaluation forms to admin. Now, as from the end of March 21, we need the evaluation forms, because if SIMC accredits a course for CPD purposes, SIMC takes the overall responsibility, the final accountability for that course. If something goes wrong with that course and people are not happy and they are complaining, the first thing that will happen is EXO will contact SIMC and demand an explanation. So as from today, all courses that are assessed by SIMC, we have to take full accountability for that course. In South Africa, the voluntary engineering associations and accredited tertiary education institutions render invaluable service in offering a wide range. This is in the voluntary association section 10. ICSA expects that the recognized VA should, where possible, as part of the activities, assist their members in identifying activities and present activities. And here is the slide that says that SIMC will be responsible for the validation and monitoring of the courses, seminars, conferences, etc. Now, category 2 is work-based, maximum of 3 credits, technical work in a practitioner's field of specialization. Any registered person working engineering for more than 800 hours per year can claim 2 CPD credits. Mentoring young engineers in the workplace and career guidance, you can get 1 credit for that. Category 3, that's individual activities. Being a member of a voluntary association such as SIMC immediately gives you 1 CPD credit in category 3. There's some additional CPD credits, part-time lecturing, supervision, oral examinations of final years, etc. Publication of technical articles, papers presented at conferences, participation in statutory, professional, institutional committee task groups. If you're part of SIMC committee, you get points for that as well. Evaluation, and this is various evaluations. Additional qualifications, self-study, this is the category 3, which our technical evenings will assist in. Now, what must companies know? Firstly, if you employ a professional, you need to understand that that person has some requirements from ICSA and needs to remain registered. They get discounts when they join a voluntary association and they will need CPD points, which means they need to go on training that has been assessed for CPD points. This is something that if a company employs a professional, there are going to be some cost that has to be incurred either by the employee or by the employer. And you need to understand that before you decide to employ a professional. Now, applying for a course accreditation, let's say a company decides they have got a training course in-house that they want to provide to their customers or to people out there, and they can apply for those training courses to be assessed for CPD purposes. Now, applying for to SIMC for such a course, and that application is available on our website. The application for CPD provider registration is in ECPD 7 of the spreadsheet. They need to categorize the event, which engineering discipline and the nature of event, etc. You'll find that in ECPD 3, which is also part of the same Excel spreadsheet. And we've developed the spreadsheet in such a way that information that you put in ECPD 7 is automatically pulled through to ECPD 3, and you just need to fill in the course relevant information, add that to that form. And then that information from 7.3 is pulled through to ECPD 2, which you need to sign. There's also another signature that I'll discuss now. And should the presenter be changed due to unforeseen circumstances, the details of the new presenter must be submitted to ICSA for review before and a motivation why it's changed, before the company can continue doing the CPD courses. Now, in that spreadsheet, you will also find a statement by the company about the presenter, that the presenter has got time and will be able to do it and has got the necessary knowledge and skills to present that information. So you can see that the whole requirement for category 1 CPD has changed from a very informal situation to a very strict formal scenario. And there's a checklist included in the application on our website for your convenience. If you download that Excel spreadsheet, there is a checklist, and you can just make sure that all the boxes are ticked. Now let's have a look at that checklist quickly. What is it that you need to provide? Well, for a first time, if it's the first time that you registered with EXA, you need to provide a valid company certificate registration. You need to provide a company profile, a valid tax certificate, processes for certifying activities, and participant attendance confirmation. How are you going to make sure that a participant is actually attending, and how do they or how are they certified? Now, I would seriously recommend that if you do a CPD assessed course, that you provide some sort of a questionnaire afterwards to make sure the person understood the contents of that event. And if that happens, it just makes it so much easier to motivate why you are giving a person a certain certificate. Agreements must be in place for venues, presenters, coordinators. If services are to be outsourced, supporting documents must be provided with detailed information. It appears that some of the other voluntary associations ended up in a situation where the people paid for a training course and the training course never happened and they never got their money back. That's an assumption that I'm making because it's only when something like that happens when people suddenly come up with all these hundreds of different additional requirements. Contingency plans, you need to provide contingency plans if certain services are outsourced to ensure that people receive their purchase CPD activities. There has to be a refund policy in place as well that SMC also needs to get a copy of, so that when the auditors come and audit a certain event, we don't need to call on you to provide us with the information. We already have it, it's on file, and you can just continue with your work while we sort out all the audit issues. Evidence of a comprehensive quality management system. Now, if you are certified ISO 9001, that will suffice. Otherwise, we're going to have to discuss what elements are necessary in your quality management system to make sure that the person who applies gets the necessary training and gets the certificate and actually attended the course, etc., etc. Okay, that is all from my side. If there are any questions, comments, or concerns, I'll be happy to take that. Thank you.
Thank you, Johann. Thank you so much for explaining the CPD process. And just to also advise the attendees today that if you would like to participate in October with a presentation and get CPD accreditation, please let us know and we will assist you with that process. Our webinars in October will allow you to get CPD points. So also for those attendees looking to earn their CPD points, please join us in October for those sessions. And now we have a very special person that's going to present and advise us on AATF and how we should participate in 2023. Over to you, Gillian.
Thank you, Vashni. Good afternoon, everyone, and thanks to all our speakers. It was an absolutely wonderful morning. We appreciate that. The Africa Automation Technology Fair is Africa's largest showcase of industrial automation, smart control technology, and the future of digitized manufacturing. The event is the go-to show for all automation and technology on the continent, and you cannot afford not to be there. So it's the chosen platform in Africa that brings together automation and technology industry experts, vetted buyers or industry decision makers, engineers, project managers, technical professionals, mining executives, and government across the African continent. It's themed from Africa for Africa, and we offer maximum exposure pre, during, and post-event in the form of webinars, monthly e-magazines, social posts, as well as emailers to the extensive AATF database. It's aimed to connect and aid in increasing business with face-to-face interactions, demonstration areas, CPD accredited industry talks, and valuable content from both local and international experts in the automation industry. So the event offers an opportunity to build relationships with your current and your potential customers. It's evolved and includes artificial intelligence, as with one of our speaking slots this morning, cybersecurity, robotics, integrated industrial automation, digitization. So there's exciting digital opportunities that we have designed to complement your existing marketing activities. So sign up today and maximize your exposure in the coming months, running up to the live event in May 2023. Reach out to me if you need any further information. We really look forward to hosting you in Johannesburg at the Expo Center from 9 to 11 May 2023. And yes, that's all from me. I look forward to welcoming you all in person in 2023.
Thank you very much, Dillian. I see that we did have some questions with regards to the CPD, and Johann has addressed most of them in the chat box. If there is anything else, you're more than welcome to email the team or Johann directly so that we can assist you with those questions. And I just want to remind everyone that we'll be continuing with the program tomorrow. So we have an exciting lineup tomorrow as well. We have the workforce retention and introduction to cobots, which is going to be presented by Omron. We also have presentations by IDC and the DTI, so that would give us a very interesting overview of the landscape and funding and financing that is available. We also have automating weather controls, as well as taking production and real-time data into the cloud from Android Technologies. We have the digitalization of mining by Ingrid Osborne, and we have a presenter from the US tomorrow also doing what is hybrid manufacturing and just giving us an overview of that. So we look forward to seeing everyone again tomorrow. Please feel free to share the link wide, and we hope to see you tomorrow. Have a good day, everyone. Thank you.